And just as Mark had emphasized, it is costing a lot of money, billions of dollars each year, but yet it's incredibly difficult to predict, and it's difficult to forecast how big it's going to get, exactly who will get hit. So you don't know if you're going to be the one that's facing that price tag. To kind of dive deeper into why it's so tough to forecast, let's bring in Dr. John Allen. He's an associate professor of meteorology at Central Michigan University, who's been studying the science of hail forecasting and why it's still such a mystery. Doctor, thank you for being with us. Let's start with the basics, just the 101 on all of this. What are the ingredients that people need to know about? What's in the atmosphere for this to produce that large hail?
So key to having hail production is some sort of strong updraft. And so we see these associated with what are called supercell thunderstorms, these rotating thunderstorms. They tend to produce a lot of the biggest hail we see, things that are 2 inches and above. These storms arise when we have significant amounts of instability. That's a difference in the temperature between the surface and aloft. We have the presence of a lot of moisture near the surface, and so as that is released, we get a thunderstorm updraft. The other ingredient that tends to be critical is that we have some sort of changing wind direction and speed with height. So if you see clouds moving at different layers in the atmosphere as you look up, that's a good example of wind shear. That allows storms to organize and become stronger, last longer, and start to produce hail. As little embryos are drawn up into the thunderstorm updraft, they hit a region around about -10 to -30 degrees Celsius, where they start to grow. They accumulate supercooled liquid water, so water that just freezes on contact, and they start to grow very rapidly. Storms do not take long to grow very large hail sizes, on the order of 10 to 20 minutes.
Yeah, and Dr. Allen, when you look at this, I mean, look at some of the reports we had in last month alone. And I mean, it's significant in just the state of Texas. 3 different reports where you're talking about 5 inches or greater, and you just went through all the ingredients, and there's a good understanding of what needs to happen in the atmosphere for that to happen with the large hail, but it's so tough to predict those areas that are going to get hit. Why is that the case?
Working out exactly where storms are going to form is a really difficult problem. And there is a project that is going on this spring, beginning around about May 18, that's actually going to be out there trying to answer these questions. Look at why are hailstorms forming? Why is hail growing so large? How is hail size distributed across them? But it's a very difficult and challenging problem, and we really haven't had good observations of hailstorms other than those that come from the general public for the past 4 decades. So hopefully, following this summer, we'll have some new insights and some new opportunities using weather radar and similar to be able to provide better warning and better anticipation of these threats.
And Dr. Allen, oftentimes during the severe season, we talk about instability. That's what fuels severe weather. Especially in Texas, we're looking at the dry line igniting this for areas like the hill country out towards I-35. Is there a point, though, where too much instability actually prevents those storms from producing large hail?
Yeah, so as we increase the temperature, we can suspend more and more water in the atmosphere. As you put more and more water into the updraft of the thunderstorm, it actually acts as a little bit of a brake. And so eventually, you don't tend to grow hail in the same way. That being said, there's a lot of different ways to grow large hail. The US has the largest hailstone that's occurred in the world, around about 8 inches in diameter, which you can imagine is an enormous hailstone. But how these stones actually form varies from storm to storm, and we really don't understand what drives that production, whether you're going to get lots of small hail or some of the really big stuff.
Yeah, we've already seen this week, Dr. Allen, where one is coming down at, a DVD-sized hail. Everything else seems to be about 2 inch in diameter. So there's just that one that was massive, and everything else widespread blanketing the road was considerably smaller, but still all creating damage, and that's the point of all of this. You and I at home, we have the price tag of that, and we want to know that awareness ahead of time. So in the future, I know this is something that we really want to focus and study. Do you believe that there's going to be more lead time in advance that, hey, large hail could be knocking on your doorstep and banging on your roof?
So I think it would be great for us to be able to say more about the sizes we're expecting, right? Different sizes have different implications. Smaller hail generally doesn't do a lot of damage. As we get up to that 2 inch and above, that's where you can think about putting your car in your garage. You can think about mitigation strategies to maybe prevent hail from doing quite so much damage. I think that there is a decent chance that we're going to be able to offer some insights into that. I don't think necessarily lead time is going to maybe have the same effect that tornadoes has, but for groups like photovoltaic solar plants, they need that lead time to stow in a way that means they don't get damage from these. So I think that there's a few different groups that have different needs when it comes to hail forecasting, and hopefully we'll be able to meet those needs in the coming years.
It's a fascinating topic, something that we're going to learn a lot about in the years ahead. And overall, it's a great opportunity to kind of dive into the science of this and a better understanding. Dr. John Allen, thank you for being with us tonight here on Fox Weather.